Today we're looking at this webinar, Wireless Connectivity, Enabling the Next Industrial Revolution. It's from the Alpert research team. And it really dives into the convergence of wireless communication with Industry 4.0 and 5.0. So we have this incredibly diverse toolkit of wireless technologies. But what does this all really mean beyond the specific standards themselves, the potential for Industry 4.0 and 5.0?
The sheer power and flexibility come from the sophisticated functionalities embedded within them. Let's start with 5G flexible numerology. It allows the network to scale the subcarrier spacing and the symbol duration in the radio signal. In simpler terms, it means the network can dynamically adapt its radio waveform characteristics on the fly. For example, it can use wider subcarrier spacing for high bandwidth applications where spectral efficiency is key, delivering more bits per hertz. Or it can use shorter symbol durations and narrower spacing for ultra-low latency applications that need minimal propagation delay and rapid signal processing. This flexibility is revolutionary because it optimizes resource allocation to meet vastly varying quality of service, or QoS, needs simultaneously. A single 5G network infrastructure can efficiently support a multitude of different industrial applications, each with highly unique and often stringent latency, bandwidth, and reliability demands. It can handle URLLC for robot control, eMBB for video analytics, and MMTC for sensors, all at the same time on the same physical network without compromising performance for any specific use. Next, we move into the higher frequency bands. mmWave frequencies, generally 24 to 100 gigahertz, are used in 5G. They offer incredibly high capacity and ultra-low latency, but usually over shorter ranges because the signals don't travel as far or penetrate obstacles well. Moving even higher, the T8 band, that's 100 gigahertz up to 10 telehertz. This band promises ultra-high data rates, potentially terabits per second, and extreme spatial reuse, meaning more devices can communicate simultaneously in a small area. Now, because of their very high frequencies, these signals have limited range and get absorbed easily by obstacles, even the air itself to some extent, but that characteristic actually makes them ideal for secure, high-capacity links within specific, confined zones of a factory. So these frequencies are critical for future applications needing massive bandwidth and extremely high-resolution sensing within defined industrial perimeters. Multiple input, multiple output. This technology employs a very large number of antennas to serve multiple users or devices concurrently within the same time and frequency resources. The core principle involves advanced techniques like spatial multiplexing and highly precise beamforming. The network can essentially create multiple independent spatial streams and direct radio energy very precisely towards individual devices. This minimizes interference between users and maximizes the signal quality for each one. The benefit is a significant improvement in spectral efficiency, meaning more data can be transmitted effectively over the same amount of spectrum, and a substantial increase in the overall network capacity and coverage. In dense, smart factory environments, massive MIMO is crucial. It drastically improves signal quality, reduces latency by ensuring more reliable and dedicated communication paths, and helps guarantee better coverage, even in complex and challenging radio frequency conditions often found in factories with lots of metal and moving parts. The evolution to multi-user MIMO extends this capability further by enabling multiple users or devices to simultaneously share the exact same time and frequency channel without significant degradation in performance, further boosting network capabilities for industrial applications and allowing a single access point to efficiently communicate with many robots or sensors. Beamforming is a sophisticated signal processing technique. Instead of broadcasting a signal in all directions, it precisely focuses the wireless signal towards specific devices, like a spotlight. This optimizes communication, reduces interference from other signals, and improves the reliability of links, especially in complex industrial settings with lots of metal and obstructions. Together, massive MIMO and beamforming are crucial for handling the immense traffic and precise communication needs in advanced manufacturing. The integration of time-sensitive networking, or TSN. Its fundamental principles revolve around achieving deterministic communication, guaranteeing bounded low latency, minimizing jitter, variations in latency, ensuring high reliability, and enabling precise time synchronization across the network. The exciting development is that these TSN principles are now being actively integrated into wireless technologies, most notably 5G, creating 5G TSN, and Wi-Fi 7. For 5G specifically, this means the 5G system can effectively act as a TSN transparent bridge. Ensure that time-critical industrial control messages, adhering to TSN standards, can traverse both the wired and wireless segments with guaranteed end-to-end latency and reliability characteristics. TSN integration fundamentally bridges the historical divide between the information technology IT world and the operational technology OT world in factories, enabling true industrial convergence and unified control over mixed wired and wireless networks.
How about tailoring the network itself to very specific needs within a single factory? almost like having multiple dedicated private networks on demand, but using the same infrastructure.
That's precisely the promise delivered by network slicing, or NS. It allows for the creation of multiple independent end-to-end logical networks, often called slices, all operating efficiently on a common physical network infrastructure. Each network slice can be individually designed, deployed, customized, managed, and optimized to meet the specific performance and functional requirements, like latency, bandwidth, reliability, security, of various types of data services or different business operators or even different departments within a single enterprise. Each slice comes with its own guaranteed quality of service, QoS, ensuring that the diverse needs within a single factory, or perhaps even across interconnected sites, are met efficiently, securely, and crucially without interference or resource contention between the different types of traffic. It provides unparalleled customization and isolation of network resources. And closely related to network slicing and equally transformative for industrial users is the concept and increasing adoption of 5G LAN-type services and fully private networks. This involves deploying 5G networks, and potentially future 6G networks, privately. This means the entire 5G system, including the core network functions, is contained within the logical and geographical boundaries of defined premises. This private network operates entirely independently from the public cellular network, giving the enterprise complete control over its operation, configuration, and data. It offers greatly enhanced security, as all sensitive industrial data traffic remains within the factory's controlled environment. It also provides unparalleled control and customization over network parameters, things like latency targets, bandwidth allocation, device prioritization, and security policies. Integrated sensing and communication represents a fundamental shift, a breakthrough where traditional communication functions, sending and receiving data, and sensing functions, detecting and characterizing the physical environment, are seamlessly integrated into a single system, often using the same radio signals and hardware. The network infrastructure itself becomes capable of performing both roles simultaneously. The transformative impact is that the network essentially becomes a kind of distributed, pervasive sensor grid. This allows it to do much more than just transmit data packets. It can also actively use its radio signals to detect motion, identify the presence or absence of objects or people, estimate distances and angles, map object shapes, or even track movements within its coverage area, all while potentially communicating data at the same time. ISAC essentially turns the network from a mere communication pipe into an intelligent, perceptive entity that understands its physical surroundings. Optical Wireless Communication, OWC, is also gaining some traction. Technologies like visible light communication, VLC, using LED lights to transmit data optical camera communication, and free space optical FSO links are being considered. They could be used for device-to-device communication or even for high-speed backhaul fronthaul networks within a facility. OWC offers an alternative high-bandwidth, potentially very secure communication method for specific scenarios, especially where traditional radio frequency RF interference is a major concern, or where you have clear line of sight, like between two machines close together, or inside a clean room where RF might be restricted. So, Industry 5.0 isn't just some far-off idea anymore. It's actually happening now, it's evolving, and wireless communication is right there at the heart of it, enabling it all. Organizations that really lean into wireless innovation, they're the ones who will unlock smarter production, more resilient supply chains, and ultimately create value that's sustainable and human-centric. As this whole industrial landscape keeps shifting towards being more autonomous, more intelligent, more adaptive, well, how quickly and effectively companies adopt and integrate these wireless technologies, that's really going to shape their competitiveness long term. If you're interested in digging deeper into this whole transformation, we absolutely recommend checking out the full analysis. It's titled Wireless Connectivity, Enabling the Next Industrial Revolution, prepared by the Alpert research team. You can find their presentation on the future of the wireless industrial revolution at the link provided in our show notes.